This is also a relatively short chapter. We are now moving into the third part of this book, which is uh, titled as The Public Health Approach to Climate Change. There are various issues like disease surveillance, climate justice, health justice, right to health, etc. are going to be discussed, including what's in the future. So this chapter, chapter 11, is about improving the surveillance of climate-sensitive diseases. I think you already know what that means, but here is a schematic showing a conceptual model of influences on the population's health, another way to look at it. So we are focused on population's health in the context of place and time. So we have natural environment, cultural context, and political context, which we have been discussing in various ways. And we have community attributes that include social attributes, biological characteristics, built environment, health services, economic resources, population-based health programs, and collective lifestyles and health practices, which tend to be culture-specific, region-specific, and so on. Okay, this kind of a figure has been presented in several papers. Maybe the first version came from Jonathan Patz. I used the version in my 2009 paper as well. Essentially, this is a good way of looking at how climate change is not always directly relatable to health effects. There are many intervening factors, and we have seen this in many ways already. So we will see this here in terms of how maybe this kind of a mapping helps surveillance of climate and climate sensitive diseases, right? So here we are with the natural causes causing climate change. We include El Niños, the North Atlantic Oscillation, Pacific Decadal Oscillation, orbital forcing on longer time scales, ice ages, and so on. But we have also driving forces such as population dynamics, unstable economic development, with greenhouse gas emissions being the proximal causes. And then we have now actions to deal with them through adaptation and mitigation. So that is the natural climate change, which is going to feed into the regional weather changes. So often we are trying to adapt to regional weather changes or mitigate weather changes, including air and water quality and so on. So that's going to impact heat waves, extreme weather, temperature, and precipitation, which we have been talking about. Then that directly also impacts microbial contamination pathways, transmission dynamics, agroecosystems, hydrology, socioeconomics and demographics, and eventually leading to health effects, temperature related, extreme weather related, air pollution, water, foodborne, vector-borne, zoonotic effects of food and water shortages, mental, nutritional, infectious, and other health, which drive other evaluation options and strategies for adaptation, including health-specific adaptations and research and so on. So this can drive specific observational systems which can bring together to health surveillance and climate sensitive diseases considered more specifically. Starting with the environmental monitoring, we have a large number of satellites now that are always in orbit, and new ones are replacing the ones that are undergoing their lifetime expiry. And there are of course terrestrial observational systems on all these islands, which include radars, weather stations, balloons being sent up to monitor various gases, temperature, humidity, precipitation, clouds, radiation, winds, and so on. There are always efforts to improve these systems as well, and oceans have their own set of observing systems which can be anchored to the bottom like these red squares here, or they could be specific. So these are often designed to improve weather and climate forecasts, such as tornadoes, cyclones, storms, just regular weather, sometimes also extend to air quality, ozone, pollen, and so on. But there are also coastal observing systems, El Nino forecast improvements, storm surge inundation, and so on and so forth. Some of them have some things that are related to ocean ecosystems and potentially to health, like upwelling indicators, CO2 and oxygen monitors, and so on and so forth. But none of them are specifically designed for health as such, or health outcomes as such. There are post facto efforts to take those data and develop prediction systems for harmful algal blooms or pathogens or air quality, water quality, and so on and so forth. So typically a conceptual framework for public health surveillance would go like this. This is from CDC in the US, the Center for Disease Control. So you have public health surveillance. So this is not necessarily climate sensitive disease surveillance. So there are slight differences, but obviously many overlaps. So they include health surveys, which CDC carries out, registries, so systematic and continuous collection. This is the other resource, so that's public health surveillance, which includes systematic and continuous collection, analysis, and interpretation of data, closely integrated with the timely and coherent dissemination of the results and assessment to those who have the right to know, so that action can be taken. And registries here mean vital registration, cancer registries, exposure registries, and so on. Information systems include medical and laboratory records, pharmacy records. Environmental monitoring is what we looked at, weather, climate change, and pollution. Clinical and public health research and other data sources such as criminal justice information, LexisNexis, and census data, which show socioeconomic patterns, neighborhoods, vulnerability to diseases, information on education of women, age groups, per capita GDP, and so on and so forth. Okay, so I will leave it here and come and talk about specific types of health surveillance systems that already exist, and then we'll look at what are some of the suggested improvements going into the future and how decisions can be supported by these systems, and how risk maps can be used as well as outcome of the disease surveillance, and then conclude with some of the ways that weather and climate forecasts can be used to produce early warning systems, and also to produce vulnerability map and risk maps, and so on and so forth. Okay, so some people would not agree that there is some specific surveillance needed for climate sensitive diseases, but it seems obvious that with the increasing heat waves, storms, extreme rainfall events, floods, droughts, related agricultural impacts, and so on, it makes sense to have a system that actually considers environmental impact on health, and the surveillance system combines both to develop decision-making processes and health preparedness, as we called it before. Okay.